Okay, this question's going to go through 2D. All right, so trying to identify my redox pairs, what's being oxidized, what's being reduced. Now, this is a reactant, this is a product. We can see they look very similar. Okay, so I'm going to make up a skeletal equation with those two species, and my other skeletal equation is going to involve that species and that species. Now, you might be wondering, what about the hydrogen ions and the water? Well, we're just going to ignore them for the time being because neither the water nor the hydrogen ions are being reduced nor oxidized. And we can't really tell that at the moment because we haven't learnt the skill of oxidation numbers, okay? But we know that we often add the hydrogen ions to balance and water to balance as well, so that kind of gives us another reason that we can ignore them for the time being too. So these are my two skeletal equations. So this is being, we can't tell if it's being oxidized or reduced yet, okay, but we'll know that pretty soon. And this is my other pair here, okay, that's undergoing either oxidation or reduction. We're not sure which one yet, you know, we're not sure if it's being oxidized or reduced yet because we haven't learned oxidation numbers, but we will soon. Okay, so let's start by balancing this half reaction. So I've got, check you've written that out correctly. Yep, good. All right, so key elements, nitrogen, nitrogen, that's good. Oxygen, I've got one here, I've got three there, so I need to add two hydrogens, two waters rather. Okay, might just start this again because I haven't given myself too much room. Okay, so two water plus one is three, so oxygen is balanced. Hydrogens, I've got four there, so I'm going to add four hydrogens. Okay, now electrons, overall charge on this side, 4 plus minus 1 is plus 3. Overall charge on this side is 0. So I'm going to have to get these charges to be the same. The only thing I can do is add electrons, so I'm going to add 3 electrons there to bring that down to 0. So that balances out, balances out the charges. Now we can see we actually have an oxidation reaction. Okay. Our last step is just to add the states. So aqueous, aqueous, liquid, and gas. Second half equation. Okay, so let's balance this one. 2 chromium, 1 chromium. I'm going to add a 2 there to balance the key elements out there. 7 oxygens here, so I'm going to add 7 waters to balance out my oxygens. So I've got 7 oxygens there, 7 there. Hydrogens, I've got 14 hydrogens. None on this side yet, so I'm going to add 14 hydrogens. That balances. Charge, now I've got 14 plus 14 here, minus 2, so that's a plus 12 on this side. On this side I've got a plus 6. So I'm going to have to add 6 electrons to balance out that charge. And my last step is just to add those states in. Okay, so now what I can do is add my equations together. And I always need to check that my electrons are the same value before I do that. Okay, so 6, 3, the smallest number that 3 and 6 can go into is 6. So I don't need to multiply this by 1 because that would be a bit pointless. So let's multiply everything here by 2. So I'm going to write that out. 2NO, 4 waters, 2NO3, 8 hydrogen, 6 electrons, and this was my other equation. Alright, so now I can add them together. 2NO, so let's focus on all my reactants and write them next to each other. Okay, that's all my reactants. Arrow, 2NO3. I'm going to have to go over 2 lines here. 8H plus, 6 electrons, plus 2 Cr3 plus 7 waters. Alrighty, so now I need to think about what I'm going to cancel out. So I'm going to cancel out electrons, potentially hydrogens, and water. So got my electrons, I can cancel them. Have to be either side of the arrow. Whatever you do to that side of the arrow, you have to do to this side of the arrow. Okay, water. So water there, water here. So if I knock out 4 waters on that side, I can knock out 4 waters on this side and be left with 3. Okay, now H pluses, I've got 14 on this side and 8 on that side. So if I knock out 8 there, I'm left with 6. And that's everything. So now I can rewrite my equation. So 2NO, that was a gas, plus Cr2O7 minus, and that's aqueous, plus 6 hydrogens there. Aqueous, arrow, 2NO3 minus aqueous, plus the 2 chromium ions, aqueous, and the 3 waters, liquid. And that's the fully balanced redox equation.